Hello students, welcome back. This time round, this is assignment 3.3. So what does assignment 3.3 requires you to do? This time round, we are actually making use of matrix to answer questions with context. Okay, so sometimes commonly known as word problems, right? So how does it work? So here's a very simple example. Those of you who have the physical worksheet with you can take a look. The question goes like that. Sandy and Roger took a multiple choice test, right? The matrix shows the result of the test and the marks awarded. So they give us the results. So on the worksheet, you have this matrix and you have this matrix. Then they want us to multiply them together. Now, um, here's where things get interesting because now we have context. I think if you analyze what's actually happening here, things start to make a lot of sense because based on the context, the first row here, 14, 5, and 1, represent Sandy, right? So Sandy has 14 correct questions, 5 questions that she did not attempt, and 1 question she got it incorrect. The second row here represents Roger, right? So the row here, Roger, 15 correct, 0 non-attempt, and 5 incorrect. So Sandy, first row, Roger, second row. So when we multiply them together, we know that the first row here, 27 here, is actually Sandy, right? The 25 here is for Roger. So just keep that in mind. Then how about the columns here? The columns here, okay, the first column here is the for correct answers, right? Second column here for non-attempt, the third column for incorrect. And then the second matrix, what happened is the first row is for correct answer. Second row is for non-attempt. Third row is for non-answer. So with this context, I think you can understand why when we multiply matrix, right, the column of the first matrix on the left must match the row of the second matrix because even if with context now, you realize that they match up perfectly. 14 here will go with 2 because 14 is for correct answer, 2 is for correct answer. 5 here, the second number is for non-attempt, and the second number here, 0 is for non-attempt. And the 1 here is for incorrect, and the negative 1 here is for incorrect. So they must match up like this, match up perfectly. So especially for question that has context, word problems, when we try to multiply things together, we need to actually analyze a little bit and make sure that it makes sense. Else, the multiplication is meaningless, right? So how about we have analyzed the column of the first matrix actually matches with the row of the second matrix. Now we go on to the column of the second matrix. The column of the second matrix represent the marks awarded, right? So marks awarded, okay, is 2 marks, for correct, 0 marks for non-attempt, -1 for incorrect. So since the column here represents the marks, so when we come down to the final result, the row, we take the meaning of the row from the first matrix, which is Sandy and Roger, and the column, we take it from the second matrix, which is marks. Therefore, to analyze this, we now know that 27 here represent the marks, right, obtained by Sandy, and 25 represent the marks obtained by Roger. See, beautiful, right? And that's why we use matrix here. So if we understand how matrix work, this type of question in a single working, we manage to get all the information that we want, right? Okay, so that is the first question. So let us look at another example. So in the second question, a slightly longer question. So if you look at your physical worksheet, the question goes like that. On every weekday morning from Monday to Friday, a bus carry 10 adult passengers and 30 children, right? And on every weekday afternoon, so morning one shift, afternoon one shift, carries 20 adults and 10 children. So the question gave you a matrix C, and then they lay out this way. Those of you with the worksheet, you can look at it. So the first row is the morning, the second row is the afternoon, the first column is the adults, and the second column is the children, right? So this is the information for matrix C that's provided in the question. And then they continue to ask to say, right? On Saturday morning, it carries 25 adults and 15 children. On Saturday afternoon, it carries 10 adults and 30 children. So in part A, they want us to represent these numbers for Saturday in a matrix D. Okay, so we are going to match it up exactly the same as matrix C. What do I mean? The morning must be the first row. The afternoon must be the second row. Adult is on the left column. Children is on the right column. We want to match it with matrix C, right? We want to match matrix D with matrix C because you can see in part B of the question, we actually going to do some addition. So if the elements don't match up in this manner, then the addition doesn't make sense. You see? So that's the beauty of matrix. When we match it up, we can do addition like this, right? And then of course, multiplication in the earlier example you saw already. So addition, they must match must match. Multiplication, a different way of matching, right? Column to row. So down here, D for matrix D, this is what we have, right? 25 adults, 15 children on the morning, 10 adults, 30 children on the afternoon, right? So for part B, this time round, they say that there's a matrix E that is actually 5 times C plus D. So you have already learned how to do this. So you work this one out. This is the results. Okay. So again, since it's just addition, the context and the meaning of the rows and column didn't change. So this 75 and 165 is still for the morning, and uh, the 110 and 80 is for the afternoon, right? So you can see here morning for 75, morning for 165, afternoon for 110, afternoon for 80. Okay, and then the left column is for adults. So 75 and 110 is for adults. So 75 here you see adult, right? 110 you see adult, and then 165 and 80 is for children. So 165 you see children, then 80 you see children. So you put them in the nice proper statement like this. For each element, you can write a statement or one sentence for each element to spell out very clearly that you know exactly what's going on, right? So make sure you match them up properly. So 75 is adult, morning, Monday to Saturday. Why Monday to Saturday? This one we can deduce for ourselves, right? Because it's 5 weekdays and D is Saturday, right? So 5 weekdays and Saturday. So Monday to Saturday, right? So 75 is for adult and morning. So 165 is for children and morning. 110 is for adult and afternoon. 80 is for children and afternoon. Okay. So you see, matrix, beautiful. Okay. The context actually line up very nicely. Okay. Next part of the question. This time round, they tell us that the fare for adult is 25 cents and the fare for a child is 15 cents. Right? Then they ask us to evaluate the matrix F such that it is C times 25, 15. So this is the matrix C. Okay, matrix C, we already know it represents weekday, right? Weekday, same thing, morning, afternoon, then adult and children. So we multiply it this way, and you see it matches, right? Because we know that if we multiply this, is 10 times 25 plus 30 times 15. Then 20 times 25 plus 10 times 15. So 10 times 25. The 10 here, okay, because it's the first column here, it represents the adult, and 25 is the adult fare. 30 here represents children. So 15 is the children fare, right? So it must match up like this, right? So multiplication, the column of the first matrix here match with the row with the matrix on the right. Okay. So after that, the final matrix, right? The row, the meaning of the row will actually follow the first matrix on the left. The meaning of the column will follow the column of the matrix on the right, right? So from here, we know that the first row is actually morning, second is actually afternoon. So you can see here 700 is for morning, right? 650 is for afternoon. Then the column, what does the column represent? The column represent the fare, right? Total fare. So you need to so when we are writing down in statement to explain what the matrix is, we need to have this information, what the row represents, what the column represents, right? So 700, so we have adult and children. No, it's for everyone, right? Adult and children, both the adult and children merged together already, right? The total fare for morning, weekday morning. Yeah, you want to be as accurate as possible. Then 650 is total fare, adult and children, okay, weekday afternoon. Okay, so that is part D. Then the next part, there's another matrix G, such that you multiply with 1 over 100. Then you have this interesting thing over here, the 1 by 2 matrix, and it's 1 and 1. So what happens here is when we multiply this, actually it's just addition, right? It's 1 times 700 plus 1 times 650. Basically, it's adding up these two together. So this is the fare for the morning, fare for the afternoon. But by multiplying this together, we get the fare for the whole day, right? Both morning, afternoon, which is 1350. And then after that, 1 over 100, you get 13.5. Okay, so what does it represent? Well, it represents the fare in dollars. And that's what the 1 over 100 is, remember? Because if you look at the question, the fare is actually originally calculated in cents. So we times 1 over 100, we get it in dollars. And that's the fare, total fare for the entire day, both morning and afternoon for all the passengers, right? So this is the amount that's collected. Okay? So take some time to digest this. I hope you're handling this well. I have one more question if I'm not wrong. Yes, two more actually. Okay. So here's the next question. Next question, we have the annual sports day. And these are the medals. They give you a table from the medal, right? So these are the houses of the school. Red, yellow, green, blue, black, right? 5 rows. 1 row for one house. And then we have bronze, silver, and gold, right? For the columns. So what they want us to do is they want us to multiply the matrix M, which is given in the question, which is this the medal tally over here. And then we have the matrix A over here, which is just 1, 1, 1. So interestingly, I think you had a little experience just now when we have a situation like 1, 1, 1 like this. Basically, it's addition, right? Because it's 10 times 1, 4 times 1, 9 times 1. So it's actually 10 plus 4 plus 9. So what's actually happening when we do this? We are actually adding up all the medals, bronze medal, silver medal, gold medal, just add them up together, right? So by doing that, the rows still no change in each of the houses. So when we explain, we can just explain it accordingly, right? 23 is the medals by red house, 20 medals by yellow house, 18 medals by green house, 14 medals by blue house, and 15 medals by black house. It's very logical, right? Matrix is so logical in that sense. Okay. Next part. Okay. Next part, they want us to write down a matrix H such that HT represent the total number of medals. So what happened now is this time round we want to add up all the medals. The things we don't care of which house you come from anymore. We just want to add up all the medals. And you know that when you add up all the medals, you want to have all the ones, right? So that's how addition works in matrix. However, because the medals tally is in a column vector like this, so the H should be a row vector so that the multiplication makes sense, right? So down here we have a 1 by 5 times 5 by 1. We'll get a 1 by 1, which will be the total number of medals throughout. So you do that, okay? So HT give us 90, which is actually the total medals that's given out for the entire sports day, right? Okay. And finally, the last the next part of the question says that there's a metric S, and what it says is that if you get gold medal, you get 5 points. You silver medal, you get 1 point. One bronze medal, you get 1 point. So if we look back at our original table, right? We go bronze first, then silver, then gold. So similarly, if you want to have the S, which actually represents score, we want to have bronze first, then silver, then gold. So it makes sense to actually write it this way, 1, 3, 5, because the first row represents bronze, second row represents silver, third row represents the gold. Why we put it like this? Because down here the row 1 is bronze, row 2 is silver, row 3 is gold, because in our original table we have the column 1 is bronze, column 2 is silver, column 3 is gold. So one of it is column, one of it is row. Then they can multiply together, right? You're getting the idea? Okay. So we put them in this format, right? So, and that brings us to the next segment. So that's exactly what's happening next, right? We want to actually multiply them together. So this will tell us the score for each of the house, right? So you can see here 10 is the bronze, so 10 times 1, so 10 points, right? Over here 4 is the silver, so 4 times 3 give us the points for the silver medals, right? So 9 represent the gold, so 9 times 5 give us the points for the gold medal. So now you see why down here, because the column here is bronze, silver, gold. That's why for this matrix S, it is the bronze, silver, gold is actually the rows. So they match up. They must match up this way. Okay, so you multiply in this way. This is what you get. So that's the score. Again, each of the row represent a house, right? And then the column now is actually the score over here. The column, the meaning of the column for the second matrix here. Okay, so from here you can see that in this particular sports day, Red House have the highest points. So answer the question. The winner of the sports day is actually Red House. Got that? Okay. Right, let's move on. Okay. Next question that you're supposed to try. Okay, so this question goes like that. There's a bubble tea business, right? That has two branches selling the same drinks. Okay, so the flavors are red milk tea, mint milk tea, and yen milk tea, right? And there's a table in the physical worksheet that you have, okay, showing you some of the data from branch A and branch B, as well as the price of each cup of the tea, milk tea that's being sold. Okay, so part A, the question wants us to write down two matrices, P and Q, such that when we multiply P and Q together, we get a row matrix that represents the amount collected. Okay, so what we do is we want the amount collected means we want the money, right? So row matrix, so we go P, we write down, okay, this is the price for the red milk tea, $1.5. This is the price for the mint milk tea, $1.6, and this is the price for the yen milk tea. So we write it this way. And then over here, Q, this is the data, right? This is each row is the red milk tea, the mint milk tea, and the yen milk tea. So the row represents the type of milk tea, and the column here represents branch A and branch B. Okay, so you can see down here, since the row, each row represent a different milk tea for Q, then you see that for matrix P, each column represents a different milk tea. So you can see one is a row, one is a column. So they match up this way. So by doing this, in part B, you see when we multiply together, you see what happened? 1.5, this is the for the red milk tea, right? You multiply with 84. See? And you also multiply with 90, which are both for the red milk tea, right? And then 1.6 here will go with 70 and 65, which represent the mint milk tea. 1.8 here will be multiplied with 38 and 42, which is actually the yen milk tea, right? So you multiply them this way. Final result, this is what you get, right? So because this is 1 by 3 times 3 by 2, final result is 1 by 2. So what does this represent? Well, the row is actually the amount of money collected, right? Because we get the row of the first matrix here, P. So it's the money collected. And then the column is branch A and branch B. So this is the money collected by branch A. This is the money collected by branch B. Okay? So that's what we can do. Okay, so this is our PQ. And part C, they says that if the profit is 75%, write down a matrix R such that the PQR represents the profit, right? So very straightforward actually, because what we want to have here is we want 75%. So 75% is, of course, we know 0.75. We write it as a 2 by 1 matrix because PQ is a 1 by 2. So 1 by 2, you multiply with 2 by 1, right? So that works, that works, right? So PQ is already a 1 by 2. Multiply with R, which is a 2 by 1, we get a final result, a 1 by 1 final result. And adding, so calculating together, this is the total amount that is the profit, total profit, right? 75% of the entire thing add up together. Okay, so just do this. 306.4 times 0.75 plus 314.6 times 0.75. This is the result. Okay. And yes, that concludes the assignment for this particular chapter. I hope you learned something. It also look through your notes, study hard, and if you are still confused, make an appointment with your maths teacher, right? So continue to ask, continue to learn, and hope you do well, right? So have a nice day.